Hello history friends, May is mining month here in British Columbia, and in its honor we're going to take a moment to talk about something that is very important to miners, both of the past and the present. Underground coal mining was, and still is, extremely dangerous. There were dozens of ways to be injured or killed in a mine. You could be crushed by a runaway coal car, or fall down a chute, or just have a giant pile of rocks fall on you. But the most dangerous and insidious threat was gas. A coal mine is basically a very old swamp. Swamps are full of rotting things produce gas, and as the swamp is pressure cooked over millions of years into coal, some of this gas is compressed into pockets inside the coal seam. When you dig a tunnel into that coal seam, pockets of ancient swamp gas are punctured, releasing whatever was in there into a confined space, which can be very bad news for any humans working in that space, and mines in the Elk Valley and Crow's Nest Pass were even gassier than the average. In British and Canadian mines, these gases were called damps, from the German word Dampf, meaning steam. Black damp or choke damp was any gas that could suffocate you. It wouldn't poison you, but it would push down the levels of oxygen in the air. This included methane, carbon dioxide, and nitrogen. Stink damp, or hydrogen sulfide, was both toxic and explosive, but it also smelled like rotten eggs, so it was pretty easy to detect. Fire damp was any gas that could explode, usually methane with oxygen mixed into it. Methane is lighter than air, and so tends to hang around near the ceilings of enclosed spaces like mine tunnels, and ignites when exposed to a spark or open flame. When it was ignited, the flaming methane would usually set off any powdered coal dust that was hanging in the air, creating a chain of massive explosions through the tunnels and chambers of the mine. If you were lucky enough to escape this blazing inferno, you still had to worry about afterdamp. Afterdamp usually described any products of coal combustion that were left after the explosion, and included carbon dioxide, carbon monoxide, and nitrogen dioxide, none of which are great for you. When carbon monoxide appeared on its own, it was called white damp. Arguably one of the most dangerous gases because it was toxic and explosive, and it was undetectable by taste or smell, usually until it was far too late. The earliest method of dealing with gas, specifically methane, was with the flame of your mining lamp. In very early mines, this meant holding your lamp up by the ceiling, saying a quick prayer to a god of your choice, and hitting the deck as the methane was burned off in a flash of blue flame. But by the 19th century, things had gotten a little bit more sophisticated. Invented in the early 19th century, safety lamps had a closed-top cylinder of fine mesh around the flame, which cooled it below the ignition temperature of methane. This also meant that the light was dimmer, but most miners preferred working in dim light to being charbroiled in a mine explosion. Even though they were too cool to explode, lamp flames would still burn blue when exposed to methane, and the size of the blue portion allowed miners a rough estimate of the amount of methane in the air. Obviously, when you're dealing with mine safety, however, a rough estimate is not good enough, and in the early 20th century, a variety of non-flammable detectors were invented for methane, carbon dioxide, and other gases. Like, for example, this one. This is a carbon monoxide tester from the 1950s. This specific type of tester was actually patented by the United States government in the Second World War to detect carbon monoxide buildup in plane cabins. As you can see, I have my testing apparatus, which has some tubes and twirly bits on one end, and a fun squeezy bulb on the other. And I have this small glass tube full of sand. The little white crystals inside of this tube are actually silica gel, which is the same stuff that you find in these little white paper packages. Sometimes you'll find them inside of a shoebox or a vitamin jar, and they usually say, "Do not eat!" The little yellow strip in the middle is also silica gel, but it's been soaked with chemicals, specifically palladium sulfate and ammonium molybdate. Let's say I'm down a coal mine in the 1950s and I want to check exactly how much carbon monoxide I'm breathing. I take one of my silica tubes, remove the rubber caps, snap off the glass tips, and put it into this little hole in the side of the machine. Then I squeeze the bulb to push all the air out and let it go to allow the outside air to be sucked through the crystals as the bulb slowly reinflates itself. When it's exposed to air, the palladium in this little yellow strip reacts to any carbon monoxide present and starts to turn green. The greener it gets, the more carbon monoxide is in the air. I can tell exactly how much that is by comparing the color to the little green squares on my rotating comparison chart. And that's it! Thanks to mine safety science, I can now revel in the fact that my office is completely carbon monoxide free. Or I could if I had actually broken the glass tube back there and exposed it to air, Which I didn't, because it's 70 years old and we can't get another one. But you get the idea. A lot of people have carbon monoxide detectors in their houses. You can still get some cheap ones that use the palladium reaction. Unfortunately, this only tells you about the amount of carbon monoxide in the air if you look at it regularly, and by then it could be too late. Most carbon monoxide detectors used today, both in a coal mine and in your basement, use an electrochemical process which creates an electric current in the presence of carbon monoxide. Most of these detectors have a loud alarm or a flashing light which will tell you what's going on. Yet another way that technology allows us to breathe easier, both in and outside of a coal mine. Thank you for watching this Cabinet of Curiosity mini episode, and please join us next time.